Rational expressions, no. Radical expressions and rational exponents. Yes, they're related. Alright, radical expressions, you're already kind of familiar with this. They look like this, nth root of x. Alright, so that's the radical expression. N is a natural number. Remember, the natural number is an integer greater than or equal to 1. In this case, though, it's greater than or equal to 2. Right? We want this bigger than 2. 2 or bigger. And x is a real number, so x can be any number in there. All right. If n is an even number, then x must be non-negative. What that means is if I have a 2 or a 4, then the inside x must be positive or 0. Now, what we mean by that is if we put a, well, let me put it this way. If you put a negative number in there, then this will be undefined. Like, I know in the past we had some imaginary numbers, but in this context, we're not going to deal with imaginary numbers. So this excludes imaginary numbers, this definition here. All right, moving on. So you're familiar with this, right? We read this as cube root of 32. You know this one already. That's square root of 29. And this one's fifth root of 71. So I just want to make sure everybody knows how these are read. All right, that's a fifth root of 71. Special note, this square root of 23 is the same as if there were a 2 here. Okay, so this is the one time when if there is not a number, we are assuming that that number is 2. So when the n is of nth root of x is not written, we assume that that number, the missing number, is 2. Okay, so the square root of 23 is the same as this, and they're read the same way. They're both square root of 23. All right. All right, and we already know what square root means, like square root of 9. Everybody knows square root of 9 is 3 because 3 times 3 is 9. So a square root of a number is another number when multiplied to itself gives the original number. So 3 times 3 is that number here. 3 times 3 gives me the 9. So square root of 9 is 3. Cube root of 8 is 2 because 2 times 2 times 2 is 8, right? So cube root of a number is another number when multiplied to itself 3 times gives the original number. So what is the nth root of x? The nth root of a number is another number that when multiplied to itself n times gives the original number. So like the fifth root of 32, here 32 is all those, 2 times 2 times 2. There are 5 2's here, right? 5 2's, that produces a 2. All right. So the fifth root of 32 is 2. Now this is the product property of roots. The nth root of a product is equal to the product of the nth roots. I know that's kind of difficult to understand in words, but here's the example. If I have cube root of 16, it's the same as cube root of 8 times 2, and we can split that up. It's cube root of 8 times cube root of 2. All right, and then we can find the cube root of 8, which is 2, and cube root of 2, nothing happens with that. The algebraic rule looks like this. It's the nth root of AB is the same as nth root of A times the nth root of b. So this line right here is where I'm actually using the property here, right? This line over here, cube root of 8 times cube root of 2 is actually where we're using this property. Okay, actually though, most of the time we're going to take it from the right-hand side to the left-hand side. So this is interchangeable. The rule is interchangeable. It doesn't have to go from left to right. It can go from right to left. Quotient property of roots. The nth root of a quotient is equal to the quotient of the nth roots. Now this does come up where you have square root of 25/16 and people get confused, but all you got to do is split it up. What's the square root of 25? What's the square root of 16? Square root of 25 is 5. Square root of 16 is 4. So that is a very useful rule because people do get confused on that one. Alright, so the algebraic rule basically looks like this. The nth root of a over b is the same thing as nth root of a over the nth root of b. Okay. Now, here's where the rational exponents come in. When we have a 1 over n as an exponent, that indicates the nth root. So here, this is 16 to the 1/4 power. That's equal to the 4th root of 16. And we know what that is. That's 2. Well, if you don't know what it is, work it out, right? 16 is 2 times 2 times 2 times 2. There's 4 2's in 16. Well, here's the algebraic rule. If you have a to the 1 over n power, it's equal to the nth root of a. Alright, now what if there's an exponent on there? And that's what this is. The exponent m over n, right? In the last one, there was a 1 on top, so In this row, we're saying it's not a 1 on top, it's some other number. So like here, this is 8 to the 2/3. That's the same thing as cube root of 8 to the second power. Okay, and we know what cube root of 8 is, it's 2. And then you can square the 2. So here's the algebraic rule. A to the m over n is equal to the nth root of a raised to the m power. So here's an example of this at work. We're going to rewrite the expression negative 125 to the 2/3 and radical form and then simplify. So this is the exponent, and now we're going to write it as a radical, right? The denominator here is 3, so it becomes cube root of that number of negative 125. And that 2 is the exponent up here. Cube root of negative 125 is negative 5, and then raise it to the second power. And that becomes 25. Now we're going to go the other way. We're going to rewrite this as an exponent. In this one, we can't do much, so we leave it alone. That's it. So here, the fourth root, that's in the denominator, the power 3 is in the numerator. All right, next example. Here, this one actually you can do something with. You have cube root of 11 to the 6th power. Rewrite that as an exponent. That 6 is in the numerator. The cube root, the 3 is in the denominator. Well, we know what 6 over 3 is. 6 over 3 is 2, so that's 11 squared. We know what 11 squared is. It's 121. Okay, I think that's it. Yes. All right, so that's the video. Sorry it's late. I did lecture on this today. These are basically the same notes I gave in class. All right, that's it. And the PowerPoint will be available on Schoology.